inquiry 5. For inquiry 5, to make and verify conjecture, okay, to make and verify conjectures that composite function f gx and g f x is equal to x, such that function f and function g are inverse to each other. So let's understand the activity here. The f will bring 1 to 1, 2 to 2, 3, and then 3 to 5, and 4 to 7. Okay, this is f, and the function g will bring back y to x. That means the function g is the inverse of the f. So the arrow diagram on the right shows the discrete function of f's that maps set x to set y, and the discrete function g that maps back set y to set x. So complete the empty boxes, okay, based on the arrow diagram. So now let's complete. f1 is 1, f2 is let's see, f2 is 3, then f3, if we look at that, it should be, let's write down, f3 it should be 5, right? If you look at that, it should be 5. Okay, let me write properly. And then f4, right, we have one more, f4 will be 7. Okay, g1, let's see, g1 will bring the 1 back to 1. g3 will be 2, right? g3 will be 2, and then we have the g5 will be 3, right? 5 will go back to 3. Alright, g5 will be 3, and g7 will be 4, right? Okay, so gf1, f1 is actually 1, that means g1. Okay, g1 will be 1. Okay, fg1 will be f1, so you will get 1. Alright, so the next one is gf2 is equal to g3, you get 2. You notice that these two are the same. fg3, you get f2, you get 3. Okay, now f3, gf3, what is f3? Let's refer back. f3 is 5, right? f3 is 5, so it will be g5. g5 will bring the 5 back to 3, right? Okay, so fg5 will be fg5, we will get 3, right? g5 will be 3. Okay, so we write f3 will be 5, right? So gf4, f4 will be 7, so it becomes g7 will be 4, right? Okay, so fg7, f4 will, right? g7 is 4. You can look at that. The g7 here is 4, and then f4 will bring, function will bring 4 back to 7, right? So after you complete the activity, from the result, what is the conjecture? You have to write down the conjecture that can be made regarding the values of the fgx and the values of the gfx. So what is the conjecture that you can make? Is actually you can write like this: fgx is actually equal to x, right? Alright, where x is the domain of G. Okay, and then gfx will be equal to x also, where x is in the domain of f, in the domain of g just now. So as I mentioned to you from the result from the inquiry 5, the function f and g are inverse, right? Are inverse function of each other if and only if fgx equal to x and gfx equal to x. X is in the domain of f, and here x is in the domain of g. Meaning that, okay, you can say that in short, you can say that this g, okay, this one is very important. G is actually inverse of the f, and here the f is actually inverse of g. So you can write as g like this equal to x, and here you can write as f x equal to x. Okay, the domain of g, x must be in the domain of the g. Here x must be in the domain of the f. Alright, this is a very important concept. Okay, so for inquiry 6, okay, you have to carry out this one. Scan the QR code or visit the link on the right. Okay. Okay, after you click on the fx equal to half x, alright, you need to take note of the graph obtained. Then click the box gx equal to 2x, that is inverse of f, and take note the graph display. So complete the domain and range of the graph of f and g in the table shown on the right. And then what is the conjecture that regarding to the result of the findings, and how are the graph f and g located with respect to y equal to x, and what is the conjecture, right? So if you go through the activity, okay, the domain for the function f, it should be x. Okay, the range of value of x starting from 0 to 8. Okay, the range should be the y value, or actually the fx value from 0 to 4. So graph of function g, the domain is, again I explained, the x is starting from 0 less than 4 inclusive of 0 and 4. And then for the function or the y value, is greater equal than 0 and less than equal than 8. Okay, so please identify the domain and range of the function f and g when you do the inquiry 5. So the conjecture is, okay, for this one, if two function f and g are inverses of each other, then the domain of f equal to the range of g, and the domain of g equal to the range of f. Right? So as you can see, the graph, actually they are actually, the graph G is the refraction. Okay, the graph G, let's write down the graph G graph of G is the graph of G is the refraction of graph of f on the line y equal to x. Okay, so from the result of inquiry 6, it was found that these are very important. So it was found that f and g are inverse function of each other, then the domain of f is equal to the range of g, and the domain of g is equal to range of f. Right? And the graph of g is a refraction of the graph of f in the line y equal to x. So this is a very important concept that you must understand. If you don't understand, you scan the QR code, you do the activity again. Alright, using the technology, you will have a better understanding after you do the inquiry. Okay, so please always try to do the inquiry on your own so that you will have a clearer picture, okay, on the subject about the inverse function. Okay, let's see the inquiry 7. The inquiry 7 is a very important inquiry because this one is actually to make and verify conjecture that if the point AB is on the graph of f, then point BA is on the graph of G. This is very important. AB on the function and BA on the inverse function. Alright, so scan the QR code or visit the link on the right. Okay, I have actually scanned, and then I actually post a video for this inquiry. You can go through. So you scan the QR code and visit a link, and then on the box fx equal to x squared, and from the range x 0 to 3, and its inverse function gx from the range x 1 to 10 inclusive of 1 and 10. And then you click the box point and refraction. Point and refraction is very important. You drag the point A along the graph. Note that the point on the graph F and G, you can observe the point, okay, for the changes. Okay, what is the conjecture that can be made regarding the point that is observed on the both graph? Carry out discussion and then try to answer the inquiry. So we try to answer this one. So what is the conjecture? So for conjecture that we make is for any real number. Okay, for any real number, any real numbers A and B, if the point A comma B is on the graph, is on the F, on the graph of F. Okay, let me write. Okay, numbers is on the graph of F. The point BA just now was AB on the graph of G is the reflection of the point A comma B on the graph of F in the line of reflection y equal to x. Alright, so you can actually copy this one. For any real number A and B, if the point AB lies on the graph F, then the point BA lies on graph G, which is actually the inverse of F. The point BA lies on the graph G, alright, which is the inverse of F, is the point of refraction of AB, which is lies on the graph F in the line of y equal to x. Okay, this is a very important conjecture that you must understand. Okay, to determine whether the graph of a function has an inverse function, you have to carry out the horizontal test. So if the horizontal test cut the graph of the function at only one point, then the type of function is one-to-one function, and it has an inverse function. Conversely, if the horizontal line cut two or more points, then this type of function is not one-to-one, and the function has no inverse function. So let's see this example. Okay, let's conduct the horizontal test. So horizontal test, this one, we have one intersection point. So the f have an inverse. Yes, it has an inverse. For this one, if we use a horizontal test, we have two intersection points. So the f does not have an inverse function. Alright, so the horizontal test is important. Okay, so let's see next one. Okay, so this is actually the example. Determine whether each of the function has an inverse or not. So what you need to do is you have to use a horizontal test and then give a reason for your answer. If for A, the function, it is a function because this is a discrete function, so you don't have to draw, and you cannot draw a horizontal line test. So it is one-to-one function with every elements, okay, every elements in the domains mapped to only one image elements, okay, in the codomain. So the inverse of this function also maps every element in the codomain to only one element in the domain. So the function has an inverse function, right? So it has the inverse function. Okay, when the horizontal line, the horizontal line is carried out. Okay, the horizontal line cut the graph function at only one point. So this means the function is one-to-one function, and the function has inverse function for the B, right? You can just draw like this. You can draw like this. Okay, so obviously this one horizontal test is telling us it's a one-to-one function, thus the function has an inverse function. So for the C, if we draw the horizontal line test, it seems that it intersect at 2 points. So the conclusion is when the horizontal line test is carried out, the horizontal line cut the graph function at 2 points. This means the function f is not one-to-one function. Thus, the function has no inverse function. So this one no, this one yes, right? So for the next one, this one is about the finding the, okay, let's see this one. Verify the function fx equal to 3 minus x and gx 3 minus x over 2. Verify. So we try to substitute g sub g into f, so we will get x. So since the f gx, so we have to highlight equal to gfx. If we do gfx, we also get x. If we do fgx, we get x. So that means the gx, fx and gx is the inverse function of fx, alright, because we are getting the x. Okay, so how about this one? The function f is defined as fx equal to x squared minus 6, and the domain is starting from 0 to 4 inclusive of 0 and 4 on the same plane. So you're asking to sketch a graph for the function and the inverse function and state the domain of inverse function. So basically when you want to sketch the graph of the function, is actually a quadratic curve, x squared minus 6 for the y. So we need to plot the point, okay, in the table like this. Alright, so we have to find the point. So after we plot the point, we actually found out that the graph of the inverse f is the reflection of the graph f in the line y equal to x. So the domain of inverse function is the range of the function. Okay, the domain of the f. So domain of the f. Okay, let's highlight the domain of the f. The domain of the f is from 0 to 4 right here. I'm highlighting using the red pen. Okay, let me change the red color. So this is the domain from 0 to 4, from 0 to 10. Okay, for okay, from negative 6 to 10, right? For the y, negative 6 to 10. For the x is from 0 to 4. Okay, so let's see. The domain of the f inverse is the range of the function. Hence, the domain of inverse is x from negative 6 inclusive of the negative 6 to 10. X greater equal than negative 6 and less than equal 10. That means the x is here. This is the x, okay, for the domain of the inverse. Alright, so this is actually very important when we find the range of the inverse. Okay, so let's see this example 18. The diagram on the right shows y equal to fx passing through p10 and 36 on the same diagram. Sketch y equal to inverse a function of f by showing the point corresponding to the pq. So how to sketch this is the graph of y equal to inverse function is the reflection of the graph y equal to fx. So in the line y equal to x, so the point p prime and q prime on the graph y equal to inverse corresponding to the point p and q on the diagram on the right. So you can actually draw a line to show they are actually vertical distance. They are the same, right? Okay, one is object, one is image. This is object, this one is object, this one is image. And this is the line of reflection y equal to x. Okay, so basically these are the concept of the graph of the inverse function. Okay, so about the domain, I think some of you are not so understand. So I'm going to explain this one again. Alright. So let's see this example. Okay, some of you are actually not so sure about this. So the graph of f define fx equal to x squared minus 6. Okay, the domain is x from 0 to 4. Okay, so let's see x squared, the original graph, x squared minus 6, where is it? It's in red color, right? It's in red color, so I draw again. So this is the graph. Okay, so the x is from 0 to 4. Okay, the x is from 0 to 4. When we talk about x, we always look at this side. Okay, we always I highlight in green color. This one, 0 to 4. This is called domain, domain of the function. From 0 to 4. Domain of the function. On the same plane, you are asking to sketch the graph of the inverse, okay, of the f. Okay, f negative 1. You are asking to sketch. So now we are going to sketch the graph which is in purple color of f negative 1. Okay, so basically if you want to sketch a graph, you have to know how to go about the inverse. So if possible, we try to draw this y equal to x. then we will find the point, this point, the blue one will go to the red point. Okay, it reflect at the purple line, so we will do refraction. So this is the image, and then here another point, and for this point the image will be here, reflection. All right, and then for this point -6, you will go to here, right? You can see the distance, you can join and see the distance between them. It should be equidistant. All right, it should be equidistant, right? Okay, all these are equidistant. Perpendicular distance should be equal, right? Okay, so the purple line is actually line of refraction. So if you sketch the graph as shown, so you can find the point when x is 0, y is -6. When x is 1, -5, 2, -2, 3, and 3, and 4, and you will get 10. So if you inverse back, the inverse of f is refraction of the graph in the line y equal to x. So what you need to do is you find the point that reflect on the line, purple color line, and then you draw the curve using the concept of refraction. Alright, so the shape should be almost the same, something like this. Okay, this is a point on the line of refraction. Okay, so the object and image will be on the line of refraction. So basically there is a concept how you sketch the inverse function. Okay, for example like this one also, we try to draw the line of refraction first, which is this one. Okay, passes through origin. It must go through origin. Okay, this line, it must go through origin. Okay, and then you try to refract the point. You try to refract the point on the purple line. Okay, so the concept is like that. So we will find this point. Okay, we will find the point, and then image will go to this point with the same distance. All right, so and here you can find more point. All right, so that you won't you can find at least 2 points so that you can draw the straight line. Okay, this is the image. This is the image, the green one, and the object I'm using the blue one. This is the object. Okay, so you will notice that their distance, the distance should be the same. The distance from line of reflection to the object and image should be the same, vertical distance. So hence you can sketch the line by finding 2 points. So I'm going to sketch. You can use a ruler to sketch. It will be something like this, right? Just now the function was this one. Okay, let's use a blue color pen. Okay, the function was this one, right? So the green one is the image of the blue one. Okay, so that is all about the sketching of the inverse function graph. I do hope that you have a clearer picture on how to sketch the inverse function graph. It's a bit tough, but you can try to get the answer on your own. So we will discuss more exercise in the coming video. Alright, so maybe I will discuss question like I will try to discuss as many questions as possible. Alright, so maybe question like this which is a bit challenging to you, question number 4. Question like this also a bit challenging. And then this one maybe we discuss in my next video teaching. So please do all the exercise that I discussed in the exercise book. So that's all my sharing for today. Till then, I shall see you in my next video sharing. Bye bye and have a nice day.